Did you know that a day isn't actually 24 hours? It's 23 hours, 56 minutes, and 4 seconds. This is the time it takes for Earth to rotate on its axis, known as a sidereal day. This fact might seem insignificant, but it's a revelation that changes our everyday understanding of time. Think about it. Every day, we're 4 minutes short of what we've been conditioned to believe is a complete day. Those minutes add up, and to correct this discrepancy, we add a leap year every 4 years. It's like a little patch we place on time, a small adjustment to align our calendar with the universe's rhythm. This sidereal day, this ungraspable concept, is a reminder that time is not just a human construct, it's a cosmic dance, a rhythm set by the universe, and we're just trying to keep pace. So, technically, we've been living shorter days all our lives. Time is relative, not absolute. This captivating idea comes from Einstein's theory of relativity, which tells us that time moves slower the closer you are to a gravitational field. Mind-boggling, isn't it? Let's delve a bit deeper. This phenomenon is known as time dilation. Simply put, time dilation means that time ticks at different rates in different gravitational fields. So, an object in a strong gravitational field experiences time more slowly. You might be asking, how do we know this? Well, it's been proven by experimentation. In a famous experiment, atomic clocks on jets showed different times after flying around the world. The clocks on the jets, which were further from the gravitational pull of the Earth, ran faster than those left on the ground. So, what does this mean for us? Well, in essence, astronauts living aboard the International Space Station age slightly slower than people on Earth. Yes, you heard it right, time isn't universal, it's relative. Physics actually allows for the possibility of time travel. Now that's a sentence you might expect to hear in a Hollywood blockbuster, but it's not as far-fetched as it sounds. Let's dive into the concept of wormholes, an intriguing theoretical proposition in the world of astrophysics. Imagine, if you will, wormholes as tunnels, bridging distant points in space-time. These aren't your regular tunnels though, they're cosmic shortcuts, potentially allowing for travel to different eras in time. So yes, time travel isn't just a figment of a screenwriter's imagination, it's a concept deeply rooted in the field of theoretical physics. Of course, there's a catch. We've yet to develop the technology to create wormholes, let alone navigate through them. We're in the realm of conjecture here, but it's one that excites scientists and dreamers alike. While we don't have the technology yet to create or navigate through wormholes, it's a fascinating idea that time travel could someday become a reality. Ever wondered why time only moves forward and not backward? This is due to a concept known as the arrow of time. This fascinating idea stems from the second law of thermodynamics, which is all about entropy, or disorder. Entropy is a measure of chaos or randomness in a closed system, which always increases with time. Imagine a sandcastle on a beach. Over time, wind, waves, and other forces will eventually reduce it to a formless heap of sand. That's entropy in action. The transformation from order to disorder. This constant increase in entropy gives time its arrow, its direction. It's why we remember yesterday but not tomorrow. It's why we grow old, not young. It's why your coffee cools down instead of spontaneously heating up. So time's one-way street is all thanks to the increasing disorder in the universe. Here's the most shocking fact: time as we know it could end. This might seem like a plot from a science fiction novel, but it's actually grounded in scientific theory. Let's dive into the deep end of cosmic predictions. There are several theories about the ultimate fate of the universe, and many of these predict the end of time. For instance, the Big Freeze theory suggests that as the universe continues to expand, it will eventually become too cold and sparse to sustain processes that consume time. On the other hand, the Big Crunch theory proposes the opposite. The universe could stop expanding and start collapsing in on itself, leading to a point of infinite density where time simply cannot exist. While these are all theoretical, it's a mind-bending thought that the ticking clock could one day come to a halt. So next time you glance at your watch, remember, every second is precious, because time, in the grand scheme of things, is finite.